Okay, we're moving on to 4.6 today. We just have 2 more lessons in this unit. 4.6 is definitely the harder of the 2 lessons. 4.7 is a nice break when we get there. Our topic is functions. Very, very, very important. Your learning expectation, you can identify a function. That's what you can do today. You can tell me if a set of data represents a function or not. You need to know some vocab words. Domain is X. Domain, just think like you dominate all. And for some reason, X tends to always dominate. The range is Y. A relation is a set of points. Okay, I want to stop and do a visual here. If I give you the point 1, 5, 1 is the domain, and 5 is the range. It's still a point. It's still something that you can put onto a coordinate plane. It's still something you can plug into an equation. It's just a new name now. In the definition of a function, this is huge. For every x, for every single x, there is only one y. If x goes to more than one y, it's not a function. So a function means that for every single x, there is exactly one y. And then I have in red, we don't care how many y's there are, because that's not the definition of a function. We only care how many things an x goes to. That's all we care about. So this is how many ways to write an ordered pair. Look at, we're used to x, y. Well, x is known as the domain. Y is the range. We could also say x is the input if you think about a function machine, and y is the output. X is also always the independent variable, and y always depends on whatever x is. Okay, those are all different ways to think about x and y. X means domain, input, and it's independent. Y means that it's the range, it's output, it depends on x. Okay. So identifying domain and ranges. First thing, domain is x, range is y. What I do is I list each domain and range separately. This is how I do it. I say domain, range, and I make a little T-chart. Domain and range. Domain is x, so whichever x's I have, I put them in the domain. Range is y. Whatever y's I have, I put them in the range. So this isn't doing like major algebra, it's just identifying, knowing that domain is x. So what are my x's in this data set? 3, 4, 5, 7. That's all my domain. All I did is took out each of the x's and put it with the domain. My range is the y. So what are my y's?
4,
4, 7, 9, and only do it once. See how that's another 9? I only put one 9 down. So my different y values are 4, 7, and 9. Identifying the domain and range. Okay, my next data set, I have the points 6, 5, 4, 3, 6, 4, and 5, 8. I need to identify the domain and ranges. Domain is x, range is y. So I'm going to list all my x's down. I have a 6, I have a 4, I have another 6. Do I write that down? No, because I already wrote a 6 down. And I have a 5. My range are all my y values. So I have a 5, a 3, a 4, and an 8. Do you feel like you can, if I give you a set of data, would you be able to tell me what the domain and range is?
Yes.
Okay, that's part A to this learning target. Part B is then telling me if it's a function. So, mapping diagrams is what we're going to be doing. You're going to connect x to its corresponding y. Corresponding. Funny word. Connect x to the y it needs to go to. So you do it kind of weird. You do it like I told you, domain and range. You list your domains out, just like you did. You felt successful with that. So domain is x. X is 3, 4, 5, 7. The range is the y. That is 4, 7, 9. And now the only difference, so that's what you did on the previous page. Now the only difference is you match. You put a line to match them. So I had 3 goes with 4 on this first point. So 3 to 4, that's what you do. 4 goes to 7 on the second point, 4 to 7. 5 goes to 9, 5 to 9. 7 goes to 9. Okay, that's called a mapping diagram. It's where I separate the domain and range, and then I put a line to connect what x goes to what range. Again, separate one, domain, range. Domain is the x, range is the y. I'm listing my x's down, 6, 4, I already wrote 6, and a 5. Range are my y's. 5, 3, 4, 8. Okay, so again, nothing new. Now the new part is connect. So 6 should go to the 5, 4 should go to the 3, 6 should also go to the 4, and 5 should go to the 8. Now, if you recall the definition of a function, it says you're a function if each x goes to one y. Well, if you look here, 3 goes to one y, 4 goes to one y, 5 goes to just one y, and 7 goes to one y. It's okay that 2 things are going here. I want to know how many things are x going to. So this is a function. Because the x's go to exactly one y. Now here, this next data set, 6 goes to how many y's? 2. Right away I know it's not a function. Every x should go to only one y. If x goes to more than one y, like 6 did, 6 went to 5 and 6 went to 4. It can't do that. Then it's not a function. Function, each x goes to exactly one y. Not a function, x goes to more than one y. And let's just do random examples. Domain, range, or x and y, same thing. X is domain, y is range. Let's pretend I had 5, 6, 7, 8. 2, 1, 6. And let's pretend I had this. Let's do the same data set. And one that looks like a function and one that's not. So a function means each x goes to exactly one y. So that means each of these x's goes to something, only one thing. See? 5 goes to one thing, 6 goes to 1, 7 to 1, 8 to 1. Function. Not a function is when an x goes to more than one thing. So I'm just going to go like this. And which number made this one not a function?
7.
Yes. Now Gatlin said that really fast. Can we tell why?
Yeah.
Which one made this not a function? 7 did, because it went to 2 things. Only look on the left-hand side. Who cares about the right? It doesn't matter. It only matters with the left-hand side.